Good morning, afternoon, evening, delete as applicable, wherever you are on the planet. I am Olivier. I am joining you today for this CNCF webinar, and we're going to be talking about cloud native and what the lessons learned I've gone through myself and our team about building Cerbos in the open source world. Quickly, by way of introduction, I am Olivier. I am an engineer turned product guy. Started my career at Microsoft, but I've spent the last 10 years working in various SaaS businesses across MarTech, e-commerce, supply chain, bit of connected fitness, but always very much focused on data and infrastructure. So working with the teams that are running our big Kubernetes deployments, making use of all of the great ecosystem projects in the CNCF. And a couple of years ago, we started our own project called Cerbos, which is tackling authorization in the open source space. I'm not going to dwell on Cerbos, but at a high level, just give you an idea of what it is. It's a way of implementing roles and permissions in your application using policy rather than code. It's a scalable, stateless, decoupled approach to authorization, which extracts all the complicated business logic out of your application code base into a standalone service that you run inside of your infrastructure, and you define all your business logic as policy, similar to be used to with other kind of manifests that you're using, for example, with your cluster. Really, Cerbos, the target is for the end user applications, though it can be used from pretty much anywhere in the stack. That's what I'm going to talk about Cerbos, but I'm going to refer to it as kind of a reference for some of the lessons we've learned building this project over the last 2.5 years as an open source project, as well as being a member of the CNCF. You can find out more of Cerbos itself, cerbos.dev, find out us on GitHub, follow us on X, Twitter, if you wish to find out more. So cool. The main crux of this talk is going to be speaking about what I think and what we've kind of experienced and sort of what we've heard around what makes a project cloud native. And here it is in quotes, and the cloud native phrase. Well, what does that mean in reality? Maybe should it be lowercase c, lowercase n rather than uppercase? These are all things that we pondered a bit about, and also kind of some lessons learned looking at it. So I'll start off by saying being a cloud native project doesn't necessarily mean joining the CNCF. Now, obviously, great organization. I wouldn't be here speaking to you today if it weren't for it. It does amazing work for the community and the ecosystem, but it's a very kind of busy one. And if you want to launch a project and say it's cloud native, certainly one way of moving in the right direction is sort of joining the CNCF as a member, which we did as Cerbos. So not just saying you're a CNCF project doesn't necessarily mean your actual project implementation when it comes to reality is kind of cloud native. But for Cerbos, we did join. We are a CNCF member in the security space, and you can see our little logo amongst lots of worthy competitors in there as well, all trying to solve ultimately developer pains and developer problems. So if it's not just becoming a CNCF member and saying you're done, what really does it mean to be a cloud native project? So the next thing you say is, okay, fine, we open source the project, we publish a container, great, now anyone can go and grab it. They just run their container runtime of choice. So build it, publish a container, job done. Right, we're cloud native, you can run a container anywhere, sorted. Don't quite believe it's that also. There's a lot more to it than just publishing your app and say, great, done. Open source obviously is almost like a bit of a hard requirement these days. Open source is the future. It is how many a business and an application software really gets started. This is what we've done with Cerbos. We released this 2.5 years ago. This is actually an older screenshot, but we're over 2,000 GitHub stars now. But it's out there, it's open source, it's Apache 2 licensed. So if it's not joining the CNCF, if it's not just publishing your container, and if it's not just open sourcing your repo, what practical steps or things do you need to do to kind of get to a place where you fit into sort of that ecosystem, and what does that cloud native label really mean sort of in anger and in production and in reality when you actually have users out there? So the way I kind of think about it is, to be cloud native, you take your project and it needs to fit into the wider ecosystem. So with Cerbos, it is a authorization service. It's in the security space, but it plays nice. It's connected in. You can leverage the rest of the cloud native ecosystem and those tools and projects to essentially come up with a complete solution. because you're going to need a CI solution, you're going to need a logging solution, you're going to need a metrics collection system, you're going to need a tracing system, and making sure that your project fits into the wider ecosystem and integrates into the wider ecosystem is really what I believe is what differentiates a good project to a great project when it comes to being inside of the cloud native ecosystem. So I mentioned open source before. It's not just a matter of publishing your code onto GitHub and say, right, job done. There's more to that. So making sure you have things like a reasonable license. Apache 2, AGL, there's many to kind of pick from. But making sure that your license for your repository and your code base is one that is going to not deter people. We've seen some of the recent moves by some big projects out there to maybe change their licenses later on, which has certain consequences downstream and even impacts how people and businesses can actually use your project. So making sure you have a reasonable license in place is the first one. Code quality and not necessarily just like things like test coverage, etc., but making sure the code is grokkable, to turn a phrase. So making sure it's clean, understand, well commented, well structured, make sure it's at the right level of abstraction to really kind of understand, to allow anyone kind of jump in and understand how a particular project works and functions. One thing is once people can understand this code is like, how do you get contributors? So with Cerbos, we've actually created a load of issues with this tag of good first issue. So if people are interested to kind of contribute or support the project, even if it's something as minor as doing a typo change in a documentation, that really should be encouraged. So making sure you're highlighting those good first issues, having a clear contributor policy. So we've actually built a lot of automation in the CI pipeline to catch smaller things earlier on and making it a bit much more easier experience to contribute to a project and kind of be confident that your change is ready to go and hopefully get reviewed and accepted by the community. And then if you're in an amazing position, which thankfully we are with Cerbos, is you do get contributions from your community, like make sure you shout out to them. We publish our release notes every time we cut a release, and in there, every single user that's contributed to our code base and to the project is listed and highlighted, and their changes is highlighted, even if it was as if it was built by someone that actually is in-house or from the wider community, is everyone's on the level playing field, and really encourages that community environment. So from a code perspective, from a repo, from an organization, from an open source point of view, getting these things in line is a good foundation to then kind of build up and kind of build into the wider cloud native ecosystem. Explaining how it works. Now, this is one that's close to my heart. So I've come from kind of a background of having to wrap my head around various repos and projects and systems, and spent hours going through the code base trying to understand how the hell this particular component would plug into my ecosystem. Being able to contextualize how your particular project works with other common components in an architecture stack. So where does it sit in like ultimately the request chain, where you have some end user integrated with the application? Where does your component sit? So for example, with metrics, this is a component that sits alongside your services, and it scrapes, say, Prometheus metrics from each of the microservices, puts them into a database, and then you have dashboarding and those kind of tools on top of it. So it's a very clear way where that component fits in. And the same with whatever your project does. So if it's a database, show at what level it should plug in. If it's a gateway, what level does it kind of plug in? We've done with Cerbos, we've actually shown like the full end-to-end request flow. So actually really looking at end user use cases. They do some action. At what point does authorization and does the Cerbos project hook in, is interacted with by your system, by your application? So really contextualizing where things go. So now people have a very quick idea of like, right, I understand what this project does. I understand where it fits into the stack. How the heck do I actually use it? So documentation. Obviously, don't need to go into detail here. Everyone kind of knows the importance of docs. This will make or break a project. We did a lot of work in the early days of Cerbos of actually integrating the documentation where possible into the code base. So there's actually a whole chunks of the Cerbos documentation at docs.cerbos.dev, which is code generated from the Go code. So Cerbos is written in Go. There's comments and structs and such inside of the code base, which are extracted out during the documentation building process and then pushed into certain pages onto the doc site. And so that way we can never have a drift between the code base and the application, the code base and the docs, because the docs are generated from the code. If we go and change a configuration variable or add a new field and such, we update that in the code base. Obviously, we know through the doc building pipeline, that field will show up and be available to users to set values as they wish. So it's a really key one. Having a very solid set of release notes. So whenever we publish a new version of Cerbos, not only do we highlight which commits and such have been included in that release, but also including references and quick starts and pointers to how to use a particular change or migration path, these kind of things. So in the case where you may have a migration to be done, even if it is making sure it's a sensible migration and making sure that you have a good roll forward strategy and a rollback strategy if something doesn't quite work. How can a user upgrade a typical configuration to using the new configuration, and then making sure when you do push a change to how configuration workflows and does require a migration, what is the deprecation window? So being able to run the configuration in parallel for a little while until you're happy with it, things are stable, you release a few versions, and then what is the deprecation story after that? So with Cerbos, we're still in the less than version 1 stage, but even within the minor versions, we are keeping capabilities or changes around for a few versions after their initial release before deprecating an older one, and it just gives users that confidence that this solution is something that is set up to grow and set up to scale, and is sensible and can be relied upon when it comes to upgrades and updates. Being language agnostic. So anyone that's kind of using a lot of the CNCF projects will be kind of aware, these are generally services that you're running inside of your stack. And when you actually look at the end user applications that are making use of different projects, these are going to be in a myriad of different application languages. So there's a bit of a bias towards Go with some of the CSCF projects, but as you look at the majority of maybe end user applications, you see a lot of Node, TypeScript out there. You see PHP, .NET, Python obviously is the big one now with machine learning world, etc. So really look at how can you make sure that your project is agnostic to any particular architecture or any particular framework. So with Cerbos, ultimately we ship a container. That container exposes a gRPC or REST interface, and then the idea is any part of the application stack can then call into that service and interact with it and get kind of authorization decisions without it being coupled to any particular application. So we have a very simple API. Primarily is exposed as a gRPC interface, but recognizing that not all application frameworks are, let's say, as friendly to gRPC or takes a bit more of an overhead to understand protobufs, etc. We've also put a REST wrapper around it, so straight off HTTP REST style API on top, which ultimately sits on top of the gRPC service. And then also to make that onboarding experience as smooth as possible, we have SDKs. So we've done a lot of work to code gen the SDKs from the protobuf definitions for the gRPC interfaces. And then as a user of Cerbos projects inside of your application architecture, at the point where you want to check permissions, you don't have to worry about constructing gRPC channels, you don't have to worry about securing, you don't have to worry about formatting the calls, etc. You're getting a type-safe SDK in your particular language, and you just point it to which internal service where Cerbos is running, typically inside of your cluster. So be a service and make sure you provide sensible SDKs on top to allow users to plug in as simply as possible. Being infrastructure agnostic is one that takes a bit of thought in terms of how to design and set up, and obviously we're now in the world of containers, but what we've seen kind of from the usage of the Cerbos project is not everyone is just using Docker containers. So for the Cerbos project, we distribute the container, we distribute binaries. So through our pipeline, we generate binaries for the OSs as well. We have a number of users that actually just essentially install the Debian package onto a node when they're running Cerbos. They're not in Kubernetes or anything like that. So how can we fit into that environment? And there's environments where people want to check permissions that you can't even run at runtime. So we actually distribute a WebAssembly module as an option also. And so really understanding, where is your project going to be used, and not use your community, use whatever feedback you can get, speak to the contributors, etc., and really understand, where is this application, where's the service going to be run. Containers is a pretty good bet these days, but I was even surprised that we did have users asking for binaries and WASM modules and such. So we kind of did the work and put that in out there, and there's usage of these other methods of running, which maybe you wouldn't consider if you're just thinking like Kubernetes. So really understand the infrastructure that your end users are using. When it comes to the container itself, be sensible about base image. So using something like Scratch or Distroless as the base images, obviously it makes it smaller. It also removes a whole load of attack vectors when it comes to locking down your containers and security side of things. But one thing to be wary of is actually their users, when they're trying to test and evaluate your project, sometimes want to be able to shell into the container and like run some test commands and such against it. So really think through like, what is the debugging story? If users is running your service in a container, but there's nothing else in that container besides your service, how do I get in and like maybe try executing with a different flag and those sort of things? Something to be kind of aware of. Being sensible around health check endpoints. So Kubernetes obviously is big one for this, but maybe users are using things like Docker Compose, or they're running directly on bare metal with a load balancer doing health checks, etc. Having an HTTP endpoint for a health check is the fairly common practice one, but we have users that are running Cerbos in like serverless environments where the infrastructure will just exec a command inside of the container. So we've created the Cerbos health check endpoint command. So you literally exec the Cerbos CLI tool with a health check input, and then evaluates and returns a status response. So it's not always going to be an HTTP check. So what is the story for your project when it comes to health checking? MTLS support. So it's all very well saying like we ship this nice microservice, you write it in your stack, etc. But these are going to be running environments where there's going to be restrictions and rules around locking down that environment and making sure everything is secure. And inter-service communication is one of those aspects. So it's thinking about, okay, the API you expose out, how can you do things like mutual TLS? This has just been a hard enterprise requirement for some of the Cerbos users to date. So we've added support where you can mount your own certs, and then the server inside of the Cerbos server uses those mounted certificates to do TLS. And then really thinking through like what's the certificate revocation story, those sort of things. You just want users to destroy your pods if they roll the certs. But having these capabilities in place, and possibly maybe consider a bit more of an advanced requirement. But if it does come to it, this could be a make or break for someone actually deploying your particular project. Then when it comes to deployments, kind of mentioned this already, Kubernetes obviously is a big one, but how can you make that easier? So for Cerbos, where you want to have a service running inside of your cluster, we've done things like publish Helm charts, and there's variants of those for having a service or a daemon set or a sidecar, etc. Sort of how do you inject the container into the right point in the stack? Looking at other environments, so things like CloudFormation templates, ECF definitions, Cloud Run Knative definitions. How, if your service is capable of running kind of ephemerally and statelessly, how do you run it inside of Lambda or these other kind of serverless function type environments? What about edge functions? What about environments where you just want to run a WASM module and not have to worry about actually running a full fat service? How do you support those? And there's all kind of really think about, again, where your users are and what environments they're running in, and how you can best support as many runtime environments that make sense for your particular project. One thing I will say is around hosted. Really have a think through around is your project something that you would want to be a managed service or a hosted service? In the case of authorization, we have been staying away from a managed decision point. Because architecturally you don't want to be going out over the internet to some managed hosted version of a service to check authorization permissions, because this is going to be in the blocking path of every request. And the moment you're going out of your network, out your cluster, off your node even, over the internet to do a permission check, that's going to add tens of milliseconds of latency, which is going to add tens of milliseconds of latency to every single API call that's coming into your system, which isn't a good design. So Some projects makes complete sense. A hosted, managed version is certainly a way to monetize an open source project, but really think through, is that the right way you as someone that would maybe using your project would actually want to architect and design an application layer. So after your infrastructure layer, you then have storage. So if your project needs to persist data, how do you make that pluggable? So in the case of Cerbos, the way LTV works is you're loading an authorization policy. These are YAML definition files that define who can do what under which circumstance, under which conditions. And we wanted to make sure that we had a way of having a sort of a agnostic pluggable backend for different storage mechanisms, because we knew our users are running all sorts of different environments and they have different controls and constraints around how they can bring in configuration stored data into the runtimes. So, storing on disk either by mounting a volume or a config map is kind of an obvious one, but allowing you to pass in credentials to like a cloud storage blob, so S3, GCS, Azure Blob Store, these kind of things, and how can you use that as storage backend? Git repos. So GitOps is very much here to stay, I think it's safe to say at this point. How can you actually use a Git repo as a storage backend, and what is the whole GitOps story around it? Allowing users to basically provide credentials to a Git repo hosted somewhere, and then actually have your runtime pull down on some regular cadence. The configuration from there enables you to actually have a long-running service, but dynamically change the configurations, or in this case, with authorization policies for Cerbos on a regular basis, and allow users to basically set up those polling and reload and caching intervals, etc. When you think about your getting started, when you think about more dynamic use cases, does there need to be a database? Okay, great. What database? Well, SQLite, Postgres, MySQL, MS SQL Server, etc. There's a plethora out there. We're now at a good point where, especially in Go, there's some great abstractions around it, so you can actually make this a pluggable backend. So one environment might be using Postgres, another one might be using MySQL. SQLite is now gaining more and more popularity at this day and age. So like making sure your application storage and configuration is pluggable to different database backends. And then it's just a configuration flag to set up what that backend is another approach. And then really, if you really think of like what's the least effort involved for a user to try out your project, you don't want to have to worry about spinning up storage or backend or provisioning a cloud bucket, etc. What about providing a way of doing like in-memory of storage? So for Cerbos, if you start it up without defining any configuration flags, you literally just start the server. It will read policies in from disk, or you can actually dynamically create policies on the fly, and they're just stored in memory, and they're ephemeral in that case. But it's a really quick way of getting up and running without having to set up a load of infrastructure or any other auxiliary services. So again, kind of being agnostic to your particular storage layer. Great. So the next layer down, configuration. So mounting configuration is a bit harder than you'd think. With Cerbos, we actually went down the route of making this extremely pluggable. So you can provide a configuration file directly. Again, it's just another YAML file. When you start up the server command, you point it to where that file is. Job done. But then being able to override things around particular flags through the CLI flags command, or using environment variables, or allowing environment variables to be interpolated inside of a configuration file it is kind of another important one. So when you're deploying your project in different environments, how do you provide the environment-specific context? You may want to have a base configuration file, but override it using particular values from the environment, for example. And then secret handling. There's different ways of approaching this. Kubernetes obviously has a number of different ways of doing it, but your secrets might be coming from a secret manager tool or a secret store type tool. So how do you kind of inject those into the container? Do you use environment variables? Do you support interpolating those into the config? Maybe you just want to override it on the CLI. Really have a think through like what are the different configuration flags? What's sort of static? What would you maybe want to have dynamically change based on environment? And what needs to be injected at runtime from a secret store, and think about how that goes in. With Cerbos, we kind of found out quite early on that getting users to getting a configuration file into the relevant environment where Cerbos was running actually wasn't as simple as we thought for a lot of people. You may not have the ability to push a binary and a config file to an environment. So how can you basically just override things with either CLI or environment flags is a big one. So really think through what is your configuration requirement, how do you make it environment specific, and how do you provide overrides and sensible defaults where needed. Strong API versioning. In a ideal world, you have a super successful project, which I'm sure you're all working on, but how do you make sure you don't break anything down the line? So people will be building whole application architectures or further products on top of your projects. So how do you make sure you don't break them in future changes? So using something with a strong API contract, Cerbos, like I mentioned, we use gRPC and with the REST layer on top. So we have protobufs that define absolutely everything inside of Cerbos, not just the external API, but all the internal definition types as well. But equally, you can go and use something like GraphQL, which gives you that strong schema, and you can version that, etc. And if you go down to the next level, and actually, how do you strongly version by using things like a version number in the URL or a header or such, or even in the path, to really allow users to pin themselves to a particular version of an API is kind of crucial. And going back to the documentation point, when you do make a change, what's that migration story that goes with it? And then basically ensuring that you have strong validation in the service and at the SDK level. So it's all very well having strong validation kind of at your API layer, but if your SDK doesn't enforce it, it's actually going to be quite a broken developer experience, because your SDK, you've put in some values, etc., all good, but then the SDK calls the actual your project running in the backend somewhere, and the request gets rejected. Not good. So going back to actually generating SDKs from the service definitions and all the protobufs or whatever you're using for your API layer ensures that it's going to be a smooth experience, and making sure you have that strong validation at both layers of the stack. And as I kind of mentioned, using these strong definitions, not just the external interfaces, but even the internal versions as well. And these are predominantly going to be open source projects. You want people to extend them. You want people to contribute and evolve and build amazing new products on top of your projects. Having strong definitions of even the internal data types, which can then be reused and extended, is a key one to make sure that everything kind of keeps working as you'd expect. So when it comes to logging, you got your app deployed, you've got the container running, you've got the storage sorted, your parser configuration, etc. Now the actual service is running. What's the logging story? So configuring the log levels is very kind of an obvious one everyone's sort of used to, but also splitting out the logs between different types. So in the case of Cerbos, there's two types of logs. We have the request logs, which is like the raw application logs, HTTP in and out, gRPC in and out. And we have the audit logs, which is the actual output, the decisions, which in case of authorization is the bit you want for compliance and such. So actually we have support for multiple output formats for each of those. So you can route each of the log types to different locations, and then you may have downstream log collectors doing different things. And we use pluggable syncs for this. So standard error, standard out are the obvious ones, which are great. And if you're in an environment where you've got a log collector running, Fluentd, one of these type of solutions, amazing. But you can also configure it to just write out to a specific file. And that's where you can actually start splitting out the logs into different files based on what they are, or levels, or source, or module, etc. But also having different syncs for things like Kafka. So Cerbos now has a community contributed Kafka sync for its logs, where you can provide the broker, and it will write directly to the particular topic you provide. Then really thinking like, right, my application produces logs, it's writing out to certain places, but really where are they going? In some cases it might be just dumped to a bucket and be done with it, but think about end users who are going to be pushing these logs into either commercial tools, Datadog, Elastic, etc., or into things like Loki or these other, again, projects, CNCF projects and open source projects that do things like logging. So really understanding where it goes. And the final point around logging, if you're working on your project, if someone's using your project locally, when you want to kind of understand what's going on, you want a bit more a human readable version of your logs. But then when it's in production or an environment that's fully kind of spun up, you probably want a more structured logging using something like JSON lines. So again, really even detecting TTY of terminal connected and those sort of things to really enable users to see different versions of the logs based on whether it's a human looking at it or whether it's some log collection system looking at it, and using the structured logging where it makes sense. Metrics. I think it goes without saying, Prometheus and Grafana dashboards are kind of the way in this ecosystem and the cloud native world for doing things. So Cerbos, we obviously, the project and produces Prometheus metrics, but we also do things like publish dashboards. So inside of the Cerbos repo, we have a Grafana dashboard defined. You can pull that into an instance, point it to your Prometheus instance that has the Cerbos metrics in it, and it lights up straight away. So you don't have to go through the manual process of building your own dashboards. We kind of provide an out-the-box one to get you up and running. And it goes beyond that, not just providing the dashboard, but if you're using something like Alert Manager, what are the things to look out for? Guidance on what metrics to watch when in production, which ones you can ignore in the scenarios where maybe something's not working as expected. Initial pathfinding to which metrics to go and check out first. So just spitting out Prometheus metrics is not really enough. You need to go the next level down, provide the dashboards, provide the manager rules, Alert Manager rules, provide the insights of here are the things you really need to watch when you go into a production environment. And tracing. So it's all great. You got the logs, you got the metrics. Now you want to really understand your application performance. OpenTelemetry support, OpenTelemetry as a whole project, and that whole ecosystem is amazing. So doing that little bit of extra work. So firstly, not only expose spans from your application and your project, but also making sure that all your SDKs pass the relevant tracing headers through as well. Because it's all very well providing insights and instrumentation into what your particular project does, but really from a person building an application, you want to understand a much wider context and making sure that your SDKs are passing the headers down into the project, into your particular project, and then back up so you can get the full request spans and tracing ability and all the benefits that come with it. And then telemetry. So this is one more of the controversial topics, and definitely here be dragons, as it says. So there's a balance to be made here. As someone building a project, you really want to have an idea of how users are using your particular project, what's being used, under what scenarios, in order for you to basically prioritize new features, new capabilities, and understand different use cases that people are using your project. But on the flip side, particularly when this is infrastructure running in environments, you want to, in most cases, lock it down and make sure that there's nothing leaking that you didn't want or such. So with Cerbos, we took a kind of an approach where there is telemetry, but every single time you start the Cerbos instance up, we give you a log message that tells you either it's enabled or disabled. We tell you how to enable it or disable it right there in the initial log. And then it points you to our website where we list out not only what's being collected, but also how we collect it and what the data structure is. So we link off to the protobuf definition of our telemetry object, so you can actually see what the fields are. And we also kind of called out how we're actually doing the data collection. So in this case, we use Rudderstack as a managed service that collects the telemetry collection endpoint. And we also called out in the documentation who has access to it. In this case, it's Zenorth, which is the company behind Cerbos. We, as kind of employees of the company, can see that data, but we're not hiding anything. It's completely visible in the code base of what's being sent, what's being collected, the structure of it, where it's been sent, etc. And we also make it extremely clear at startup time how to enable or disable the project telemetry inside of your particular instance of the application. So I believe telemetry is okay as long as you're clear with your users what's being collected and also how they can disable it very, very easily. You shouldn't be trying to hide the fact you collect telemetry, because that's just a bad place to be. And just to kind of wrap up a final point, this is a bit of more of a marketing, more on a technical sort of point and side of things. Obviously, you want people to use your project. You wanted to get as much traction as possible, and believe it or not, it is actually possible to kind of do sort of success stories or case studies of users of a open source project. So you've probably all seen quotes from people from users of projects in the GitHub repo, etc. We've gone one step further. We've actually spoken to some of our largest users, Envoy, Utility Warehouse, Blockchain.com, who are using Cerbos today, and we've actually managed to do full-on case studies and success stories with them. So even though it's an open source project, they're not paying us anything, they've just taken it off GitHub and run it all themselves, there's still kind of an interesting story to tell to help fellow architects, developers, decision makers around which solutions to use, regardless of the commercial or open source. There's still a story to be sold and sort of insights that can be provided around how a business or a project adopted some solution, how long it took, the savings involved, any particular insights into the best practices, etc. Pull all these things out, and you'd be surprised that you can actually get case studies, even for an open source project. But really make sure that the insights in those case studies are really, really focusing on the developer experience, because you're building an open source project in the cloud native world. We are all ultimately developers here. We are trying to get other developers to kind of save some time and remove a few headaches and providing solutions to those. But you can do that in a way that is still kind of more of a classical case study type approach, but really focusing on the developer side of things. So just to wrap up, for me at least, for a project to be cloud native, it really is your project mixed in with the rest of the ecosystem. So playing nice, having the integrations, having the best practices in place, having all the right hooks into the other parts of the cloud native ecosystem available, leveraging other parts of the ecosystem for metrics and monitoring and telemetry, being storage agnostic. All these concepts ultimately is what I think makes a cloud native project successful. But really, it's just play nice with others. We're all in the same game. We're all trying to build amazing technology and build amazing systems and delivering great products to our end users. And why not leverage what's out there? You don't want to have to reinvent the wheel every single time. If there's another great project doing the thing you need, integrate with it. Don't necessarily waste time building it all yourself, and ultimately play nice with others. So thank you very much. If you want to find out more about Cerbos, if you want to go and look at our repo, etc., go and head over to cerbos.dev. You can find everything there. And I will speak to you all online. Thank you very much.